Hi, my name is Druby, and today I'll be talking about chemistry behind masala chai, also known as spice tea. This masala chai is made by boiling water, milk, and mixture of aromatic herbs and spices, which originate in India. This aromatic herbs and spices in one drink have a lot of chemistry behind it. The spices that I'll be using today are cardamom, cinnamon, and black pepper, holy basil and peppermint leaves, ginger powder, saffron, sugar, and black tea. The main objective of chai is to extract all the flavors out of the spices. In order to achieve this, I'm grinding black pepper, cardamom, and cinnamon together to achieve maximum surface area so it can be absorbed sufficiently. So first in the pot, I added half cup of water, 1 tablespoon of chai, and 1 tablespoon of sugar. Then I'm gonna add some black peppers. Compounds found in chai are polyphenols, which are organic chemicals that help prevent degenerative disease. A form of polyphenol is flavonoid, which provides antioxidant properties. Flavonols such as tannins are converted into theoflavins and theoglobulins compounds by oxidation when boiling. This gives the color and the flavor in chai. Additionally, in black tea, amino acids such as L-theanine can be found. Amino acids are building blocks of proteins. It catalyzes alpha brain waves, which promotes relaxation. The natural color of the tea comes from the released pigment of chlorophylls and carotenoids during the oxidation process. The process of oxidation not only impacts the color of the tea, but also the taste and aroma compounds, strength, and briskness. Next, I'll be adding 1 tablespoon of ginger powder. Zinebrin is the major organic compound in ginger. The pungency of ginger is caused by a range of compounds called gingerols. When the fresh ginger is dried and formed into a powder, the gingerol compound converts to a compound called shagalol, which is twice as pungent. Next, I'm gonna add half a cup of milk. Then I'm gonna add holy basil and mint leaves. I'm breaking the mint and holy basil leaves into smaller pieces so the essential oils from these leaves can be absorbed better. I'm stirring the tea to allow all the spices to blend well. Basil gets most of its flavors from the essential oils in it. Researchers have also found various potential benefits of essential oils besides their wonderful aromas. Estradiol is one of the main molecules in basil leaves. It makes up over 50% of the essential oils, and it's what gives the basil its distinct smell. The spices tend to dissolve better in milk than water. Because fats and essential oils are both nonpolar substances, this allows them to stick together well. I also use whole milk to make chai because it has high fat content, which provides the flavor and also helps the volatile oils from the spices to stick better to the fat globules. Next, I'll add a little bit of saffron and cardamom powder. Saffron releases the color due to the degraded carotenoids compound such as crocin and quercetin, and the flavors come from the carotenoid oxidation products, mainly saffronol, and the sort of bitter taste comes from picrocin. However, saffron's golden yellow-orange color is primarily the result of alpha-crocin. Quercetin is a conjugated Pauline dicarboxylic acid which is hydrophobic and thus oil-soluble. Crocin has antidepressant properties that protects the brain cell against progressive damage, which improves inflammation. Saffron contains more than 150 volatile and aroma-yielding compounds and is considered one of the most expensive spices in the world. due to its high antioxidant properties, and it also has been linked to many health benefits. As the chai is heated, the volatility of the compounds increases. Two chemical reactions also take place, such as denaturing and tanning, which alters the protein of the milk. In denaturing, biochemical changes take place in milk when it's heated. These changes are solely dependent on the increase of temperature. In the tanning process, the milk protein turns into tannin casein complexes. Overall, there are 600 compounds found in the black tea that contribute to flavor and aroma. Therefore, it was important to steep the tea long enough to extract all the compounds out of it for maximizing the flavor. Then I'm using a strainer to catch the excess leaves and also the excess spices that are in the tea. In the strainer, there are leaves and the byproducts from the spices. The spice compounds that were added in the masala chai typically fit into two structures known as phenols and terpenes. Phenols have distinct, strong tasting flavors, such as the compounds in ginger, which are spicy and pungent. Terpenes, whereas, tend to be more volatile than phenols, and they have citric and more cooling flavors. When brewing the tea, lighter compounds such as caffeine and phenols diffuse first. Then the heavier compounds such as deflavins diffuse. And at last, polyphenol compounds such as tannins, which makes the tea bitter, will be extracted last. However, tannins binds to proteins such as casein, which is found in milk. Tannins likes to bind to the proteins in the milk rather than proteins found in our saliva. This allows us to avoid the bitter flavor from the tannins. All the spices that I added into chai had volatile oil with diverse compounds and properties that gave chai its distinct flavor and aroma. The compounds and spices have two important properties. Firstly, they evaporate easily due to their volatile properties, and secondly, they dissolve better in fats and oil rather than water. So, this was the chemistry behind masala chai.